Hello friends, welcome to session 15 on projection of plane surfaces. Like the previous session, we'll cover some more problems on rectangular lamina and set square and all that. Okay, and as I said earlier, these are all the tricky problems what could be given in the examination to test your knowledge in this engineering drawing, that is computer aided engineering drawing. Here, a typical problem will be this way, where you have to know everything. A rectangular lamina of size 30-40 has one of its sides in VP. Okay, you see here, when they say a rectangular lamina has one of its sides in VP means you have to start from the front view, sides in VP, and rotate it about this edge till it appears as a square in the front view. Okay, I've told you whichever edge is perpendicular to xy line will not reduce in length. The other edge will start reducing. Anyway, I'll come to this in this problem. Determine its inclination with both HP and VP. The opposite edge is touching HP and all that. You see here. Now, I've started from the front view because one of the edges is in VP. Okay, one of the edges is in VP. That is why I have started 30/40 rectangle in this way. A dash, B dash, C dash, D dash. When you are looking from the top, A can be seen, B cannot be seen, A bracket B. D can be seen, C cannot be seen, D bracket C. Did you follow? XY line, VP, HP. In that way, front to top you draw. Now, I've told you whichever edge which is perpendicular to XY line will not reduce in length, but this will start reducing in length. Okay. Now, if you pull it like this for certain inclination to VP, okay, this 40 mm edge, no, that will be parallel to HP. As a result, it won't change. Okay, you see here. Now, a rectangular lamina of size 35 has one of its sides in VP and rotated up this side till it appears as a square in the front view. That is why what you do is 30/40 you draw with one of the shorter sides perpendicular to XY line compulsorily, because if you make this as 40 and this as 30, when you start tilting, this 30 goes on reducing, you will never get a square. Now this make this 30 mm shorter side perpendicular to HP. Okay, when you make 30 mm edge perpendicular to XY line, this 40 goes on reducing in the front view. Okay, now you see in this position, as you see 30/40, you are written top view, front view. This distance is how much? 40. Now, once you start pulling it on when DC is pulled, okay, this top view, that 40 will remain same. 40 will remain same. Okay, that is why first stage top view and second stage top view will remain same. I'll repeat. See here, 30 mm is perpendicular. This is 40 mm. Now I can pull it this way or I can pull this way also. If I pull this way, AB will be in VP. If I pull this way, DC will be in VP. Okay. Now you see here, I can make either AB in VP or DC in VP. Okay. I can pull it. Once I start pulling it, the top view remains same. But in the front view, BC and AD lengths will reduce. Okay. But what they have said is, you pull it in such a way that front view should appear as a square of sides 30 only. Obviously, once this is 30, it has to become a square of sides 30 only. In that way, what you do is, you pull it in such a way, it should become a square of size 30 in the front view. That means front view is known. Immediately you draw the front view. 30 square you draw. A dash, B dash, C dash, D dash, 30 square you draw. Okay. And as you know very well, if you are pulling with DC such that it has certain inclination to VP here, the top view 40 will remain same. That is why first stage top view and second stage top view will be same. Now, the question asked is, for what inclination to VP it appears as a square in the front view? That is the thing asked. Okay, take the projectors down, and this front view and this top view and this top view should be same. No, take the same top view. Okay, either this point as center, cut it here, or this point as center, cut it here. If you take this point as center and cut it here, AB will be in VP. If I take this point as center and cut it here, CD will be in VP. You take any option. Okay, I have taken this option. That means I have taken the same length and AB is on XY line and I have cut it this way so that AB is lying in VP. Is it okay? This top view and this top view is same because you have moved it parallel to HP so that this 40 will remain same even after tilting it to certain inclination to VP. This will remain same. Okay, since it is a 30 square already, you have taken the projectors, taken the same length and cut it here, measure the inclination. This 41, no, this is the inclination to VP for 41 degrees. In the front view, if you observe, it appears as a square of size 30. Okay, be careful. Here, I have told you clearly, this has to be started from front view because they have clearly said one of the edges is in VP. Okay, one of the edges in VP means you have to start from the front view. And they said it should appear as a square in the front view only. When it has to appear as a square in the front view, you have to make 30 mm edge perpendicular to XY line and 40 mm parallel to XY line. If you make 40 mm perpendicular, this 30 goes on reducing, you will never get a square. That is why 30 mm edge you make it perpendicular and 40 mm edge you take in this way. Whichever is in VP, okay, this is AB is in VP and this goes on reducing. Okay, now as you see here, once it is in this way, 41 degrees to VP, it appears as a square and as you see here, AD is actually 40, BC is actually 40. After inclination, in the front view, the B dash, C dash and A dash, D dash, since it is inclined to VP, it has reduced in length. It has reduced in fact to 30 because they are given a square as 30. That is why we already taken 30 and got the inclination. Okay. That is why this you should know that right now the problem is rectangular lamina 30 by 40 has an edge in VP and rotated about this edge till it appears as a square in the front view. Determine the inclination of the lamina with VP. Okay. That is why start from front view, get the top view, compulsorily make shorter edge perpendicular to XY line so that 40 goes on reducing. Okay. Then in the second stage, what you do is since it is a square, directly draw square. A dash, B dash, C dash, D dash, 30 mm square. This is anyway 30. Then since the first stage top view, second stage top view are same, take the first stage top view with this as center, cut it here, measure the inclination. Okay. This is how the problem is completed. Now you see what they have said is, if you see AB is in VP already, I made C dash D dash on XY line. That means edge in VP, opposite edge is C dash D dash, opposite edge is touching HP. In that way, you put C dash D dash on XY line. In that way, get the top view. Now, if you look at this, beautifully you will know, looking at XY line itself, you know clearly C dash D dash on XY line. That means immediately any dashes on XY line, immediately you say they are the points lying on HP. Since it is C dash D dash, CD is in HP. And without dashes, AB is on XY line. Immediately you say AB is in VP. Okay. Now looking at this, AB is in VP, opposite edge CD is on HP, and it appears as a square in the front view. Since the inclination to VP is constant and moved, and with the reference to AB moved, the front view cannot change. This front view and this front view will remain same. I moved it in such a way with a constant inclination of 41 degrees, that is square. I rotated in such a way and pushed it in such a way that C dash D dash comes on XY line. That means edge in VP, opposite edge in HP. Okay, opposite edge is C dash D dash is in HP. You have drawn the projections for this one. Now you see here, when you draw this, if they ask you the left view, that means you should do it on right profile plane. Anyway, this is VP, this HP. I have the front view here, I have the top view here. Now I have made X1, Y1. Okay, that 45-degree line I have made it ready so that I want one left view on right profile plane. And it is obvious for this condition, it will be seen as a line, it will be perpendicular to RPP. Now you see here, you take the CD here, okay, somewhere here you get this, and AB here, somewhere here you see here, C dash, D double dash, D double dash here, this is A double dash, B double dash, A double dash. How you name it is, you are writing the left view and right profile plane, you are looking from here, okay, meet the object first and then the plane. When you're looking from here, B can be seen, A cannot be seen. That is why B double dash bracket A double dash. It is a side view, left view on right profile plane. This is C double dash bracket D double dash. That is this. Okay, you join this. You join this. Once you join this, this is the side view of the object. This is the front view. This is the top view. This is the side view. When an edge is in VP, opposite edge is in HP, with surface inclined at 41 degree, that is when the front view is appearing as a square. That is when the front view is appearing as a square, how it appears in the front view, how it appears in the top view, and how it appears in the side view I have given. And this is actually the inclination to HP. This is the inclination to VP, you can know. Okay. Now if you see here, 49 degree, 41 degree. 49 degree is the inclination to HP. 41 degree is the inclination to HP. And that is 41 degree is the inclination to VP, which you have already done. Okay, same thing you should get. This is with reference to HP. This is with reference to VP. In that way, you have completed this problem. Now, a set square problem is a 30-60 set square, as its longest side measuring 60 mm is on HP, with surface inclined at 45 degrees to HP, and the longest side on HP inclined at 30 degrees to VP and all that. It's a simple problem. 30-60 set square, you draw first. 30-60 set square, longest side, no? 60 mm you take, and from AB you draw. From one 30 degree line you draw, one 60 degree line you draw. Wherever it intersects, you get the C. Okay. Longest side is 60 because this is 90, no? Opposite to the 90 is the longest side. Okay. A, B, C you draw. And when you're looking from here, B dash bracket A dash and C dash. Okay. Longest side in HP. Whichever is perpendicular to XY line, that will be, that you can make it on HP. Okay. That is why longest side is on HP. That is why that longest side you make it perpendicular to XY line. Okay. Now you see here, B dash A dash, the longest side is this, B dash A dash, that is on HP, with surface inclined at 45 degrees to HP. Okay. This front view and this front view remain same because it is more parallel to VP. Okay. The same thing what I was telling you earlier. Okay. Once you get this, get the top view. Get the top view, A, B and C you get it in the top view. Okay. Now once you have done this up till here, you see the next thing what they are given as edge on HP is inclined at 30 degrees to VP. When they say edge on HP is inclined at 30 degrees to VP, now since the inclination is kept constant, okay, inclination is kept constant. If I rotate this lamina in the top view, okay, rotate this lamina, but when you rotate, the condition is surface inclination to HP should be maintained constant. With maintaining 45 degrees to HP constant, I have rotated about AB such that AB is inclined at 30 degrees to VP. That is why this top view and this top view remain same. Now take the projectors up and get the front view. A dash, B dash, C dash. That means this problem is a typical set square problem. Okay, XY line you draw, VP, HP you draw, longest side is 60 mm, draw AB first. Okay, whichever you want to make it on HP, that has to be perpendicular to XY line, as I told you earlier. This you make it perpendicular. Then from A draw 30 degree. From B draw line at 60 degree because it's 30-60 set square. And the intersection of these two lines you get C. B dash, A dash and C dash. Now they have clearly given longest side is in HP. If you pull this, it will be corner on HP. Okay, you have to pull this up only. That means this C has to be pushed up. Okay, pushed up. As a result, edge AB will be on HP. In fact, AB is the longest edge, which is lying on HP. Surface is inclined at 45 degrees to HP. This front view and this front view remain same. You get the top view. And this is rotated about AB with a constant inclination of 45 degrees to HP such that the edge on HP is inclined at 30 degrees to VP. In that position, I got the front view. This is the problem with 30-60 sec square. Has its surface inclined at 45 degrees to HP, edge on HP inclined at 30 degrees to VP, and the longest side is in HP. Okay. This completes session 15 and it is the end of projection of plane surfaces. Thank you. Thanks for watching. Thank you.